Hi everyone, my name is Namakula Josephine. Welcome to my YouTube channel, and today I'm reviewing a paper which is self-paced graph memory network for learner GPA prediction and its application in learner multiple evaluation based on my based on my problem, which is interpretable machine learning techniques for students' grade prediction. So, first of all, I'm going to first go in on my computational problem. First computational problem is limitations of poor GPA evaluation, and second one is identification of distinctive students using within larger data sets, and this is the link to the paper. The most 5 keywords used, one was students' performance prediction, self-paced learning, and graph memory network, distinctive students detection, and GPA evaluation framework. So first of all, I'm going to first go through each of these keywords, students' grade prediction. You can refer it to the process of using various data, such as students' demographic, academic history, and interaction with educational materials to predict a student's future academic performance. Self-paced learning is an instructional strategy where students has some control over the pace at which they are learning. So graph memory network is a type of neural network architecture designed to work with graph structured data. Distinctive student selection refers to the process of identifying students who exhibit unique characteristics or behaviors compared to the rest of the students. And in this scenario, distinctive students were those students who performed poorly. So give GPA evaluation framework refer to the traditional method of assessing students' performance based on the grade point average. So the solution to this problem, one was graph memory network, self-paced learning, and distinctive student detection. They first used graph memory network, and later on it wasn't efficient enough, so they integrated self-learning, self-paced learning into it, which formed self-paced graph memory network as the final method, as the final efficient method which they used. So so when I go to the next slide, they had a regression analysis. So they used the regression analysis in this scenario to see how students performed. So regression, first of all, regression is a statistical method used to model the relationship between dependent variables and independent variables. In this scenario, the blue dots were referred to as the common students, and the red dots, they were the distinctive students. So they suggested that they are using regression analysis as the baseline method for GPA prediction. Against within, they compared the performance of the proposed self-paced graph memory network approach in this scenario. So the datasets used, they use the NPU dataset with these features, which is the Northwestern Polytechnical University, which was in China. And in this scenario, they evaluated the dataset and the table one. It is showing blue lines. They are the distinctive students, and the red ones, they are these red dots. They are the blue, they're the distinctive, they are the common students, and red ones, they are the distinctive students. So it is shown that the difference between 480 and 520, which is showing that the distinctive students exhibit a significant gap in that scenario, and indicating that there is no or these two originate from different distribution. 5B reveals that GPA alone is insufficient for students evaluation, as distinctive students comprise individuals with varying GPAs, and 5C it is indicating distinctive students with common students as blue bars, and you can see that distinctive students here, you cannot see them. Orange, they are the distinctive students, and blue, they are what? Common students. They are, you can see 6, 9, 15, and 1, they were the distinctive students, and these were the major subjects. And in this scenario, they compare the major subjects of distinctive students with their latter common students. So the blue bars in this figure 6 represents examples of course selection of distinctive students and common students, which are used to further evaluate the findings. So the course highlighted in red boxes are unrelated to the majors and are general educational courses. So the OLAN dataset, which is Open Universal Learning Analytics dataset, is a comprehensive dataset which captures daily interaction data for students enrolled in online courses. So when I go to this side, this table indicates different tests done by both distinctive students and communist, done by only distinctive students at the beginning of the semester here up to the final examinations here. This is the key. So you can see that from this column x plus 1, this is x. I can find this as to a over a plus 1, a plus 2. I can find that from this column, the distinctive students went on decreasing, and you can see that these students here are a subset of this column here. So this figure, which is figure 8b, it is showing that there is no significant difference between distinctive students in this scenario and common students. And here it shows that there is a significant difference between them, as you can see in this scenario here, in the scores of their final examinations. So when I go to this diagram here, you can see that distinctive students referred to as red ones, they are in the downer part, and the blue students, which are the common students, the red dots, the blue dots, they are in the upper in this scenario. Whereas in this scenario, you can see the clip type 4, 6, 7, 8 in the distinctive students. It shows the this clip students that this clip for you can refer to as the forum online test. Let me show you here foraming out content homepage and quiz. Here you can see the differences between these clip tests on online learning in the online data sets. So this table here was the one which was based on while drawing these graphs. So when I go to this table was based on while drawing this graph, and you can see that the self-paced graph memory network outperformed other traditional methods, and this is the curves they drawn, and it consistently outperformed those algorithms throughout the whole semester. So this is the statistical information of the data sets we use. This is the NPU GPA data set. This is the online data set. So, and you can also here, they use the online data set alone also to see the performance of the algorithms with other algorithms, and the self-paced performance network consistently outperformed those other algorithms. So the machine learning models developed, there was self-paced performance network and distinctive student detection based on self-paced graph memory network, and self-paced performance network consistently outperformed other methods developed. This one. This table 2 indicate the proposed model self-paced performance network achieved better results compared to the graph-memory network and left down optimal when it was used on the enzymes dataset and the collab dataset. So this is the self-paced graph-memory network. It consisted of two steps: the learning step and the identifying step. You can see here this is student information, and this is the graph post information. When I got the next slide, these are the algorithms which they use well training that model. This is algorithms 2, this was algorithm 1, this is algorithm 2. So graph memory network, it used the polling method and the representation learning. So the polling method is the operation reduced the number of input nodes by questioning them, aiding computational efficiency and focusing on crucial features. So representation learning, the memory layer transforms input node features into to capture meaningful patterns and relationships within the graph. So this is the structure of the graph memory network. You can see that there are different memory networks with different memory layer keys. They are stacked on top of input queries. So this is the query network. This is the convolutional layer. Last No, not last but not least, we have convolution. These are the other algorithms which they considered. They considered convolutional network, long short-term memory, k nearest neighbors, decision trees, and naive Bayes. So the highlight process of the paper by the authors. First was verification experiment, student and performance prediction experiment, distinctive students detection, identifying limitations, exploration of students' characteristics, model development, validation and analysis, insights and recommendations, future directions. So the strengths of this model, they improved prediction performance, robustness of outliers, identification of distinctive students, insights into learning process, adaptability and scalability, interoperability, data dependence, generalization, resource intensive, evaluation bias. What I can say as my conclusion, the paper based on focusing on what were the limitations of pure GPA evaluation and the identification of distinctive students. The distinctive students were referred to those students with completely different learning characteristics, and they refer to those students as the students who learn really poorly. Thank you.